Okay, so in our investigation with the oranges, at the very end, they said, knowing that the surface area of the sphere filled in that many circles, so we saw that that many was 4, um, what would you guess to be the surface area of a sphere? So let's think about what we know when they were tracing. So here's my orange. It's my three-dimensional orange, and then they traced it around the bottom. What do we know about the radius of the tracing versus the radius of that orange? It should be, if that was essentially a great circle, that this radius here is the same as this radius here, right? So couldn't you say that if the area of a circle, of a great circle here, is pi r squared, and these radii are the same for both the orange sphere and for the great circle, wouldn't I just have 4 circles? Don't I just have 4 pi r squared? So guys, that's the surface area of a sphere. So let's go over here to the box and let's fill that in. So surface area of a sphere is 4 pi r squared. Now here's the tricky part. Surface area of a hemisphere, right? We take the 4 pi r squared, but we don't want the whole sphere. We only want half, so we're going to divide that sucker by 2, right? So we could just call this 2 pi r squared, 4 divided by 2, right? But keep in mind, that only encompasses all of this. Remember, the definition of a hemisphere in geometric terms includes this lid. So how could we, in a hemisphere, that surface that's touching air, that lid, right? How could we find the area of the lid? And the key to that is it's just another circle, right? So couldn't you say plus a pi r squared for the lid? So essentially 2 pi r squared plus 1 pi r squared, a hemisphere is 3 pi r squared. So I know that feels weird. I know you feel like, well, it's half a sphere, Miss Benton. It should just be 2 pi r squared. But it's because we have to account for that lid, is what I like to call it, at the top. That counts as part of the definition of what a hemisphere is. So we have to account for it in all the surfaces that are touching air. Okay, so here we go. Find the surface of each sphere or hemisphere round to the nearest tenth. So when they draw the line all the way across like that, they mean that to be the diameter. So if our diameter is 32, then our radius is half that. So 32 divided by 2 would be what? 16 for the radius. And then our formula, 4 pi r squared, surface area equals, so we're talking about 4 pi times 16 squared. So to the nearest tenth would be, it's a large number, 3,216 times 0.99. So if we're going to the nearest tenth, we go to the tenths place, and the guy next door is greater than 5, so we have to round up this 9, which means we have to round up the 16 to 17 meters squared. Okay, for part B, same idea, except for this time, pay attention, this is half of a sphere, it's a hemisphere. Our radius is given to us to be 3.4. And a hemisphere's formula is 3 pi r squared, right, when it's only half of a sphere. So this would be 3 times pi times 3.4 squared. So that comes out to 108.95. Again, it's one of these where the number in the tenths place, we look to the right, it's 5 or greater, so we got to round that sucker up to 109.0. And it's millimeters squared. Area is always squared. Okay, so let's look at these last two. They're those ones where you have to find the missing thing. So in example 2, find the radius of a sphere if the surface area of the sphere is 192 pi. So this is 4 pi r squared for the oh, my bad. Look, guys, it's a hemisphere. So instead of 4 pi r squared, I'm going to do 3 pi r squared. And then I'm going to substitute the 192 pi for the surface area. So to solve this, my first thought is let's get rid of those pi's. So I'm going to divide both sides by pi. And now I just have 192 equals 3r squared. So I'm going to divide by 3. So that comes out to 64. And then the last step, just square root that sucker to get rid of the square on r. And r equals 8. Okay, so let's look at part B. This time we have a whole sphere, so we're talking about 4 pi r squared. But wait, we only know the circumference of the great circle. So maybe let's dial back a minute. So 4 pi is the area of the great circle. So we'll hold on to that 4 pi r squared in a minute. So circumference we know to be 2 pi r equals 4 pi in this situation, right? And so, first of all, we've got to solve for r. So I'm gonna divide both sides. You actually can divide by both 2 and pi all in one step. So I'm going to go ahead and do that because I'm lazy and want to save a step. So that cancels out the pi, and 2 goes into 4 2 times. So my radius is 2. So now the last thing, surface area of my sphere, because that's what it asked me to find. 4 pi r squared would be 4 pi times 2 squared, which would be 4 pi times 4, 16 pi. And did it say? I don't think it said if I had to do it in terms of pi or to the nearest decimal. I'm going to leave it in terms of pi. All right, guys.